Okay, a little bit late getting started with this one. Just had a couple of issues. My software wouldn't connect to the live stream. But here we are. We're going to do 3 merit questions again. 1 on complex numbers, 1 on differentiation, 1 on integration. That gets you a third of the way to getting merit on these 3 papers that are worth 17 credits in total on the externals. Okay, so starting with complex numbers. Just get this where I can write it. Okay, so we have this equation, x equals the square root of 33 minus 4x plus 3. Excuse me. And just 1 minute, I'm just going to check on my settings for a minute. You can have a go at that question while you're waiting. Okay. All right, so we're going to do a bit of rearranging to solve this first. What I'm trying to do here is isolate the square root portion so that we can square it out. So we've got x minus 3 is equal to the square root of 33 minus 4x. If we square both sides, we're going to square this, and I'm going to be fairly laboured about how I write it out just to make sure we don't miss any pieces. And the point of doing this is to make it super clear that when we do that x minus 3 squared, we are multiplying 2 brackets, because that often gets missed. A very common mistake is to turn that x minus 3 squared into x squared plus 9 and miss the middle term that comes out of these quadratics. Okay, so if we expand that bracket properly, we'll get x squared minus 6x plus 9 equals 33 minus 4x. Okay, so bringing those numbers that are on the right over to the left-hand side, we will have x squared. Now minus 6, we're going to plus the 4. So that becomes a minus 2x. And then 9 minus 33. Sorry, just 1 minute. Just want to check that. Yep, okay, we've got everything showing. Just because I don't trust myself with simple arithmetic sometimes. Just going to double check that. So 9 take away the 33 is minus 24. Okay, so now we have a fairly simple quadratic to solve. This is going to be x minus 6, x plus 4 equals 0. So x could be 6 or x could be minus 4. Now it's really tempting to stop there, and you would have just missed out on getting the merit mark if you had. Now the reason we need to just do a bit of a stop and a check is because at this point here where we squared both sides, we may have accidentally introduced a solution that actually doesn't really work. Think about it like this. If your solution was minus 2 and you squared and you got 4, well, the 2 numbers that could have made 4 were 2 and minus 2. And only one of them is the one that we want. So we actually need to check if both of these things work. So if we check x equals 6, pop that in, 6 equals 33 minus 24 plus, and square root it, and then plus 3. So if we do 33 minus 24, we get 9, square root that is 3. We add on the 3, the 6 works fine. If we check the minus 4, we get 33 minus, it'll be 4 times minus 4, so that's a plus 16, and plus 3, and you should be able to see fairly easily this one is not going to work, because if we square root 33 plus 16, we get 7, and then add on 3, that makes 10. It's not going to give us the solution that we want. So from there, we can say x equals 6 is our final solution. Now, one thing to do to check with these sorts of equations, we can put them into equation solver on our calculator. Now, you can't get merit just by using equation solver. So if you have a merit question that you could do on the calculator, only use the calculator to check it. And show the algebra here to actually get the merit mark. That's true across all of the complex numbers paper. So let's just check it. And if you did get to this stage of having 6 or minus 4, we would then go to the equation solver to check, and then we would see that actually it only brought us one solution. So let's just do that. So checking on equation solver, if we pop this equation in here, actually let's just do the original one. So F3, we're going to do x equals square root of 33 minus 4x, and then add 3. Hit enter and then solve, and you can see it's only given us one solution here, x equals 6. And we'll just, you can even double check that you are in the mode where you're going to get all the real solutions to make sure you're not missing any. So in this case, we've got x equals 6. If you were at all unsure, then you use your calculator just to check the solutions on your calculator match what you got by doing it algebraically by hand. Okay, next one, if there aren't any questions. All right, thanks Black Monkey, nice to know there's somebody there and watching. What did you think was crazy about that you can do so much on the calculator? It is actually pretty cool how much you can use the calculator to get by on the complex numbers paper. I always think that the achieved questions in particular, if you just know how to use your calculator well, then you can get achieved on the complex numbers paper pretty easily without too much effort. Okay, so next we need to go to the differentiation one. So here we go. Oops, let's just get that back on the screen. Okay, here is differentiation. Yep, that's right, Black Monkey. A lot of the times you can put a huge amount of the algebra into your calculator and have it check it for you. There's lots of skills that can save you a lot of time on that paper. If you go back, go and have a look back on the lives that I've done in the recent couple of Merit a Day lives. There's some more tips in using your calculator on that one too. Okay, so we're differentiating this. We've got parametric equations. X is defined in t and y is defined in t. As soon as you get t involved in the middle of those things, you know you're doing parametric equations. So the first thing, we're going to differentiate each one. So we'll do dx by dt, and I can never remember whether sign goes to positive or negative cos and vice versa. So I'm just having a quick look at the formula sheet. So sine goes to cos and it stays positive. And dy by dt, cos goes to minus sine, like this. And it would be multiplied by the 2 that's inside, because we're doing just a teeny bit of chain rule here. So instead of it being minus sine t like that, it'll be minus 2 sine t. Then dy by dx is made up by doing dy by dt times dt by dx. Okay, so dy by dx is minus 2 sine 2t. And we will times that by dt by dx. Just notice this dt by dx is upside down to this dx by dt, so we need to flip this one over to use it. So that will become 1 over 2 cos t. Now if we pop those together and try to simplify, those 2's can cancel out, and we will get minus sine 2t over cos t. Right, so now have a look back at the question and check what we're aiming for. At this point here, you would be sitting on your achieved point. So how do we turn that into merit? We want to make this answer here be equivalent to the answer that was given in the question. So this is a quite nice one to get in the exam, because you know if you've got it or not, because you can get to that final answer that was shown. All right, so the bit that we can play around with is sine 2t. And if you take a look on your formula sheet for the section that's on the next like the last page of your stuff that you're looking for on the calc formula sheet, it's under double angles on the bottom left hand corner, and sine 2a is 2 sine a cos a. So sine 2t will be equal to 2 sine t cos t, and that is over cos t from the line before. And now nicely that cancels, so it equals minus 2 sine 2t. Now, a little thing to an end flourish, if you like, not necessary, but if you want to feel a bit like a nerdy mathematician, you can finish that with QED. It's Latin for quod erit demonstratum, and it's the mathematical way to say I've shown it. So the thing that you were asked to do, you've finished. It's kind of like putting a full stop at the end of your maths work. Absolutely not necessary. It's just a fun little maths thing to do. You might disagree whether it's fun or not, but anyway, that's my jam. Okay, integration. Let's take a look at that one. We've got a kinematics question here. So the velocity of an object is given here by this equation that we have for v. And we've got t is the time in seconds, v is the velocity, and we want to know the distance that the object moved in the first 10 seconds of its timed motion. Right, so to get distance from velocity, we need to integrate. You don't really have to memorize that because you're in the integration paper. So if you're not sure which way to go, whether it's integration or differentiation, for kinematics questions, it's nicely separated for you on the two different papers. So to get the distance, which we always call S for displacement, I'm actually not entirely sure why it's an S and not a D, but anyway, that's how it goes. To get S from V, we're going to integrate V. Yeah, not differentiating on this one, Black Monkey, because we are in the integration paper. So that then becomes the integral of, well, I'm actually going to bring the 5 outside just to make things a little easier to deal with. We can do that with integration. We can bring multiples out if it's an entire multiple. Okay, so now bringing the 5 out from that, if I integrate 4 with respect to t, we get 4t. And if I integrate e remains the same, but we're going to divide by the coefficient of t that's in here, the derivative of the power. Don't get confused about it being derivatives. We're just using reverse chain rule here. So when we're integrating e, we divide by what's up there with the t. So this will be a minus 3 over minus 0.2. So I'm going to turn that into a plus, and it'd be like this. Okay, so if I do... Oh, my calculator's gone a bit weird on me. Just 1 minute. Let's go back to here. If we do 3 divided by 0.2, that's 15. So I'm just going to simplify this a little bit. Where was I? Here we go. So 5 between 4t plus 15 e to the minus 0.2t. Now we need the values that we need to substitute in from the question. So what distance did it move in the first 10 seconds? That means we are going from the time being 0 up to the time being 10. So now we can substitute that in. We're going to put in 10 first of all, so we'll have 40 plus 15 e to the minus 2. And then we'll take away when t is 0. Well, e will be to the power of 0, and that will be a 1, so that'll be 1 times 15. And we'll pop that all in the calculator. Okay, so 40 plus 15 e to the minus 2, Just going to make sure I've got all my brackets right. There we go. We're going to take off 15 and then we'll times the answer by 5 to get 135.15. And the final piece, just to finish it properly, is that we are measuring that in meters. Okay, Alex, I just saw your bit there about you forgot the C. You would be right if I was just leaving this as an integral in general terms, but I deliberately didn't put the C in because I knew I would be substituting numbers in later. It was going to become a definite integral. So I can put, when we're putting the numbers in, we don't need the plus C, because what would happen is in the first one where we put the 10 in, we'd do a plus C, and then in the second one where we've put the 0 in, we'd do a plus C, and then we would subtract the 2. So the constants would cancel each other out. We'd end up doing a C minus a C. So when you're doing a definite integral here where you're putting the numbers in, you don't need the C. And that's why I used square brackets as well, because that denotes that you're doing a definite integral instead of doing a general solution where you might have the plus C in there. Okay, so that wraps up the 3 merit questions for today. Again, we've managed to do 3 merits in 15 minutes or less, which seems to be the theme on these lives. So absolutely doable for your exams. If you've done all of this practice, then you can quite easily get through merit on all 3 papers within the 3 hours that you've got. Your exam strategy should be to answer questions C and D first, and if those have gone fairly easily and you feel confident, you attempt the E parts to try and push it into an excellence. If they didn't feel good, you go back and you fill in the achieved to make sure you get the achieved point. That's where I think most people should be sitting. Where's the achieved? I am doing merit questions here, particularly because the achieved sits within these. So I'm just going to go and check the mark scheme for you. I have a feeling it's when you get to this point, that would be your achieved point here. So then if you can't sort of carry it on and get to the end, then you can still get your achieved points from it. And yes, that's where the achieved is sitting within that question, is this line just here. Let me move that box out of the way. So that getting to this point here, being able to do the integral, you don't need to simplify it. This point here is achieved. And I'll just flick back to the other questions that we did as well to tell you where the achieved point would be. If I missed that on the live earlier, achieved would have been here on the differentiation, and on the complex numbers, I think it was getting down to this point just here. But if you just give me a moment, I will just quickly go and check that against the mark scheme. So just 1 second, just need to get the mark scheme up. I'm trying to do this all on one screen at home at the moment, so just bear with. Okay, let me go back to that screen, and it was actually just a little bit lower. So getting to the x equals 6 or the x equals minus 4 was the achieved on this one. And then figuring out which of those was actually the right solution was the merit portion of that. Okay, any other questions that you want to ask while we're here and live? I will just give it a second because there's a little bit of delay between me actually speaking and, oh crikey, I've just seen that I didn't turn the screen back on when I had the, oh goodness me. I will get better at this. So here we go. This was what I was talking about for the achieved question on that first complex numbers one was back here at doing the 6 or the -4. And then deciding that 6 was the answer and -4 wasn't was your merit. Okay, that'll do us for today, and I will hopefully see you next time. I'll post to my Instagram stories of the time that I expect that I will be able to do my next live. My schedule's a little bit different each day. Oh, and just one last thing, if you're here for level 3 calculus, then you'll benefit from hopping over and seeing when Infinity Plus 1 is live. I think he might be doing a level 3 calc tonight, or I don't know. He's got a whole schedule of lives booked. So if it's not tonight, then set your timer for his next one, because he's a really, really great help, and lots of people find him useful. So I'm sure many of you subscribe to him already, but if you don't, go have a look at Infinity Plus 1 and check in for his lives. They are always at 8 p.m. on the weekdays. All right, I will see you next time.